So now that we've given you a little bit of an overview of how Java Stream internals works in terms of splitting and combining, in terms of construction and execution, let's start to delve a little deeper into the splitting phase by giving an overview of Java Spliterators. So we're going to talk about the structure and the functionality of these so-called splittable iterators, and you'll get a chance next to then see how they can be applied in practice. So a spliterator is a new type of so-called splittable iterator that was introduced in Java 8. Of course, it persists in later versions of Java as well. It has two properties. First, it can be used as an iterator. And what that means is you can use it to traverse all the elements in a source in some order. So let's take a look at what you can use as the input for this. You can use the source to be something like a collection or an array. These are the kinds of things that can be iterated over using a spliterator. So here's a very simple example. This comes from my EX13 folder in my GitHub repository. I have a list of strings, which is a famous quote from William Shakespeare, "This above all, to thine own self be true." And what we can do here is we can make ourselves a spliterator from this list. The list is called quote. So if we say quote.spliterator, that'll use the built-in spliterator that comes out of the box with the Java, in this case, array list class, because that's what's going to be used to implement this particular list. And then for every element in that list, the spliterator's try advanced method will be called. We will write code that will call the try advanced method on each element. And what will happen here is that try advanced basically combines the semantics of has next and next on the Java iterator interface. So Java iterator is kind of an earlier way of iterating through things, which splits checking for the next item and getting the next item into two method calls. The spliterator combines those into one method call. And what happens here is we are going to do something that looks like this. If there are no more elements remaining, then we're done. We return false. Otherwise, we're going to go ahead and accept the action, the next element into the action. So you can see here what would happen is if we passed in system.out : print, that's going to be the operation that prints the element. And so it's going to print the value of each string in the quote. So that's what gets passed in. And you can see here, as long as there's anything left in the underlying array list that we're iterating over, we're going to accept the print method as the action. And that's going to go ahead and print the element to the standard output. The other capability that a spliterator gives you, because it's a spliterator, not just an iterator, is the ability to split. And what that basically means is it can be used to partition all the elements of a source. This example is also illustrated in the EX13 example in my GitHub repository, although the way it's shown there is not the most interesting way. We'll talk in a second about the most interesting way these things get used. So in this particular example, we show off how to use the try split method. The first thing we do is we get ourselves a spliterator, and I name this thing second half, and you'll see why I call it second half in just a moment. Second half starts out with a spliterator that covers the entire range of the list. The next thing we do is we call this try split method on second half. And what that does is it returns a spliterator which will cover elements in the underlying collection that are no longer covered by the spliterator that invoked it. What the heck does that mean? What that means in practice is that we now get back another spliterator, which we call first half, which covers all the elements in the underlying collection from 0 to the midpoint. That's the first half. And then the try split method, which is called on second half, will update the internals of second half, so it now covers from the midpoint to the end. So now we basically split things in half. So that's what try split does. And once we have done that for this particular case, we'll see how it gets used. This is basically the way that try split typically works in practice. What it does is it first checks to see if the input is below or equal to some minimum size, which is usually 1 or 0. And in that case, a null is returned, and that just indicates to the framework can't split this any further, it's as small as it's going to be, go ahead and do your thing, which typically means call try advance. If it is big enough to be split, then the input is split up into two chunks. This object will then cover the right-hand side of the chunk from the midpoint to the end, and the spliterator that's created and returned by the try-split method will cover from the beginning up to the midpoint. And so the left chunk is defined by creating and returning a new spliterator, whereas the right chunk is basically defined by updating the internal state of this particular spliterator object. So again, we're splitting things in half, if you will. What we do then is we use the for each remaining method on the spliterator to print out the relevant part of the range of the original collection that it covers. So in this case, first half dot for each remaining will print the first half of the elements in the quote, which would probably be this above all thine, and then the second half spliterator will print out all the remaining elements, which would be something like own self be true, new line. So hopefully that gives you a sense of how this is working under the hood and what iterating means, what splitting means, and so on. Now, the particular example I gave you here is a little bit contrived, and the reason it's a little bit contrived is the way in which splitting is used is actually primarily done by the Java parallel streams behavior in the streams framework. And it's used to effectively partition the input up into atomically sized chunks, which are then handed off to the fork join pool and run in parallel as part of the parallel streams model, which of course is the beauty of the whole thing. You can run these things in parallel. For the time being, for the rest of this part of the lessons in the sequential streams portion of the course, we're going to focus on the iterator portion of the spliterator, which is used to traverse the elements of a source. The discussion about splitting will be deferred until we get into parallel streams, where we're going to go through this in great detail and show you how to implement some really cool examples of parallel splitterators. But for right now, we're just going to focus on things in sequential streams because we haven't talked about parallel streams in enough detail to motivate why we need to have that more advanced splitting mechanism in the spliterator. Now, the way this actually works under the hood is there's a helper method that's part of the so-called stream support class. And the helper method is called stream. And it's a factory method that is used to create a new sequential stream or a new parallel stream given a spliterator. And the collection interface defines default methods that provide this capability. So you can see here, for instance, we have the stream method on the collection interface, which will, as we'll see, return a sequential stream. And then we have parallel stream, which, as you can imagine, will return a parallel stream. And the way it does it is both of these methods, both stream and parallel stream, use the underlying stream support.stream factory method. They both are passed in a spliterator, but the stream factory method in collection is passed false as the second parameter to stream support.stream, whereas the parallel stream method passes true to stream support.stream. And as you might guess, the second parameter is a Boolean that's used to indicate whether to make a sequential or a parallel stream. So if it's passed false, it says make a sequential stream. If it's passed true, it says make a parallel stream. That is all handled for you as long as you implement, or somebody has implemented, a spliterator method that implements the try advance and try split methods correctly in the spliterator interface. As I mentioned before, all those things come out of the box for free with Java and the Java class library. And if you need something more customizable, then you can implement and override those methods in a user-defined way, as we will see shortly. So that's the end of the overview of Java Stream Spliterators. Hopefully now you have a pretty good idea that they're a framework with a bunch of hook methods that get called automatically by the Java Streams framework in order to take care of the act of splitting a source up into chunks. Next, of course, we're going to look at some examples that show how this actually works in practice.